Here's a test prototype I made out of acrylic to check the base joint, or the shoulder as you would probably call it, the one that's turning like this. This is the one that needs to be the strongest, needs to have the most torque and support the most weight at a distance from the center of rotation. So I was getting a little bit worried that it might not work out the way I had envisaged it would work out. And specifically I was sort of worried that my triple pulley system here might not have enough strength to lift the weight that I wanted it to, or the belts might slip, or something might just break, or the motor might not be torquey enough. Whatever the problem was, I made this to figure it out. So it's a piece of 6mm acrylic on the bottom and 3mm acrylic on the top, and the 3mm acrylic will have the two stepper motors on it, and it can slide backwards and forwards in this axis to tension the belts. And because all of the belts on here have the same size gears on them, they should all tension at the same time when this axis moves outward like that. At the moment I just have bolts going up and down to clamp it in place once it gets there, and that's actually proving quite difficult to do because you have to pull it like that to tension the belts, and then somehow hold it there and use two hands to tighten these screws and the bolt on the back. It's rather difficult to get it to work, so what I might have to do is figure out some way to have a screw that's going that way, that I can just turn this screw and this would slide back with the screw to bring the tension on, and then I could adjust it quite nicely like that. So that's the main part of it there, and over here I have my other part of the test prototype. So this is going to go on the main axle like that, and I'll show you how it all goes together in a minute. But on the other end of this I just have some weight. So this is 410 grams, and it's approximately 33 centimeters from the center of rotation here. And I'm pleased to say that this actually worked pretty well. I've had this together and I did a little bit of testing, and it was working okay apart from the fact that the belts were slipping off the side a little bit. So I've taken it apart and I've made some, you can see here I've got a big piece of FR4 on the outside of this one just as a guide to stop the belt slipping off on the problem areas. And I've put a little bit of spacer in there because you don't really want the belt to be squished in there exactly. These acrylics 6mm wide and the belt's 6mm wide too, so you don't want it to be perfectly stuck on there, although that is still pretty close, isn't it? It's got a little bit of room to move sideways. Anyway, so the basis of these triple pulley systems, or this one that I've made anyway, is a compound gear like this. So there's 96 teeth on the outside and 32 in the middle. You can see I've labelled them. I've made heaps and heaps of these, so I've had to label them to make sure I didn't mix them up, because I had 102 teeth versions and yeah, just a bunch of other ones that I was starting to get mixed up. So it's just held together with 5 2.5mm screws, and at the moment they're going directly into the acrylic. I found that you can get quite a nice, strong, secure connection just by making the hole in the acrylic a little bit small and then just driving the screw straight in. It's a little bit risky because it gets so tight in some places that I've actually stripped out the heads of these screws on more than one occasion. So I use a little bit of CRC 556 or WD-40 or whatever that stuff is, and that helps a little bit, but it's still a little bit risky. Fortunately, the acrylic has not cracked at these points like I thought it might be. A bit of a risk because there's not much space there. There's only like 2.5, well, maybe 3mm between that hole in the center there. But so far, it's all been quite strong and solid, and I really like working with acrylic. It's great stuff. And as you can see, I've put a piece of FR4 spacer in the middle there to keep that one a little bit away from the inside. So yeah, it's just a bunch of these. This particular one, I don't think this needs to have any guides along the side to keep the belt in place, because as it happens the other belts hold this one in place. But anyway, let's put this together a little bit. So we need a spacer on there. That's a 3mm spacer. Then this one goes on there like that, And then this is the crown jewel of the iForce 2D machining achievements, if I can just focus on it. This is aluminium. Looks a little bit messy on the sides there, but this took about 3 hours to make, so I'm not in a hurry to be making these gears out of aluminium, but it is possible. So I just kind of did this one to make sure it could be done with my machine. So it's a bit of a stretch, but it can do it. And this one also needed to have a hole, or holes down there. You can see those two, they are threaded, and again we just have a piece of FR4 to hold the belt from slipping off. And this one now has just enough room to fit onto the end of the motor, and now you can see why I couldn't have used one of those normal GT2 belt things, because they'd be too wide, like the screw piece that goes in. Actually, let me just grab them for you, I'll show you what I mean. So these have the screw which fixes onto the motor shaft there, and then they have the belt location to the side of it, and that wouldn't have worked here because I just don't have enough room on the shaft to do it, because this belt needs to be at that position to line up with this one. Anyway, so that will be fixed on there, and then just back off a little bit, just a little bit, and now we can still spin this one on that shaft. So it's a bit of a janky idea, but it seems to be working okay for the moment, and it's fairly low friction just with the this is just acrylic in the middle, so it's spinning directly on the motor shaft, and it's going to be pulled that way by the belt a little bit, but yeah, it's not a big deal. Seems to be working alright. So then on this axle here, or this piece, we're going to have same kind of thing, except, oops, this time we've got a couple of belt guides to stop things from slipping off, so that's just going to go in there like that. And then finally the last gear in the chain is this one, which is fixed directly to the arm itself with I'm going to go with 10 of these screws. I think 10 should be enough, but this needs to be a pretty solid connection there. So anyway, let me put all this together, and then I will see if I can show you it running without the belts slipping, and how it can successfully lift this 410 weight at 33 centimeters away from the axis. Doesn't seem to be losing any steps. It's really critical that this motor section is pulled right back this way, because even if it's just a little bit not back enough, it tends to skip, or this belt in the middle slips on the small cog at the front. But I'm actually having to pull this top plate back a little bit just for this test to make sure it works, but when it is pulled back it seems to be alright. Unfortunately, it's not very rigid in this last little bit here. When it's back that way, the tension is on the bottom edge of the belt, and when the weight goes forward over this top point, the tension comes on this point of the belt. So it's probably not very even in its movement across this top point where the weight crosses from this side to that side. And here I can actually move it a little bit too, so it's not going to be the most rigid construction. When moving it by hand just now, I noticed another problem. It's fairly smooth. It's really hard to move, of course, because it's 27 times stiffer than, I'm moving 27 times the torque of this motor. Even though it's not under power, it's still quite stiff to move. But you can see it's reasonably smooth. And when I get to about here, all of a sudden becomes very tough, and I can't move it without jumping any. It starts to jump if I try and pull on the main arm at that point, but I can keep it moving a bit more by turning this and get it past that sticky point. And I have no idea what is causing the stickiness. So the only thing I can assume is that the central bore of probably one of these gears here is not quite perfectly centered, so that as it turns around this way, when we get to a certain point, it's actually pulling these belts to be further apart than normal, and they get a bit sticky. So it doesn't seem to be a problem when the power input is coming from the lower speed side, or higher speed, lower torque side. But when it's coming from here, it is a problem. Like that. Still, I think it's reasonably safe to say that this is a feasible way to do it, pending any further brain waves. I think I'll just go with this system. But anyway, this is probably all the torque I need. See there, it's going almost to horizontal. I can't actually make it go completely horizontal because this piece of the arm will hit onto the bottom bit, so I'll need to expand that a little bit in the future. But you can see that that's pretty good. It's almost horizontal, and keep in mind that what we're lifting here is 400 grams at 33 centimeters, which is actually about 2/3 more, 1/3 more than I need. So as far as stress tests go, this is looking pretty good. Oh, crap. Let me just pull this back a bit more, see if I can fix that. Ah, shit. As soon as I say it's going well, what was that? What did that happen? It's still hitting on there. Come on. I think the problem is that because my cutout here wasn't big enough, I've had to file it away a bit there. And you can see that even now, it's not quite big enough, and this belt and this belt, well, it's loose now because I've turned it upside down, but this belt and this belt are actually touching on here, whereas the belt in the middle is completely clear of it. It's all the way up there. So when the tension comes onto these belts, it doesn't come onto them equally. It comes onto the outer two first, and the one in the middle doesn't actually get to tension fully. So hopefully, when I make my next prototype, I'll cut this out in a big gap around here, and we won't have that problem. For the end effector, I made this little prototype out of, yes, acrylic, of course. And you can see it's sort of on a double hinge. Well, I'm not really sure what you call these hinge things, but it keeps that point parallel as it moves around. And it moves like this, so you just need one servo to move both sides. There's a little bit of slop there, but I don't think it really matters too much. It could be improved, I suppose. But this is just the first iteration. Well, actually, you can see some other ones that I made already, but I guess this is the third, technically. But, oh, what's going on here? Yeah, it's a little bit dodgy at times, but I think it's just the servo is tough to move, that's all. It's a Emax ES9051, pretty small. Seem to be decent strength though, even though these small servos are pretty strong still. And I had originally had two of these tie rods, so you can see I had one here and here, but I don't think it's really necessary. And it actually makes things trickier to manage because you need to get the length of the tie rods exactly the same, otherwise as it turns around, one of them becomes too long and one of them's too short. So you might as well just have one, and it seems to work pretty well. So let me just turn this thing on and I'll show you. And just by luck, actually I'm not sure if it's about 4 months ago that I designed this stuff here, and I'm only just sort of really putting it together as a proper movable, controllable test at the moment. But I was going to say, just by chance, it seems that the limits of movement of the servo are exactly where the limits should be. You can maybe hear it struggling a little bit there. I'm not sure what to do about this when the arm closes, because the servo is going to be struggling, and I don't know how servos work, but maybe do they burn out if they're, so say you put something in there and then you tell it to close and you can hear that noise that the servo is struggling to move to where you told it to move to. Is that bad for the servo? I have a feeling it probably is. So I'm not sure how it should be controlled if you want to keep it safe so that the servo doesn't get damaged. But anyway, so the 90-degree movement, or is it 90 degrees? Yeah, it looks like 90, a little over 90 degrees, but whatever it is, it works out quite nicely so that the 1000 microsecond servo pulse and the 2000 pulse are exactly at each limit of the range of movement. So it's quite convenient. I won't have to calibrate my control when I'm opening and closing it. I'll just set it to 1000 to 2000. And it's not super strong, but I don't really need it to be. I just want it to pick up, I wanted it to be able to pick up 2 centimeter cubes, so you can see it's easily going to open up to 2 centimeters. These squares are 1 centimeter on the desk, and I can pick up something like that, and whoops, going that way. It's a little bit tricky with the acrylic because it's slippery, so I'll have to put a little sticker of something a little less slippery on the inside of the gripper there, and maybe double them up so that I've got a couple of these, you know, sort of like that, so that there'd be 2 or maybe even 3 sets of these final pieces that are, you know, give some more surface area to pick things up. But this surface on the screwdriver is slightly grippy, and that lets me pick up the screwdriver, which weighs 20 grams or so. I think it's easier if I do that. And it's actually not too difficult. Oh, it's actually holds on to it pretty well. So that's all I really wanted from this. I wasn't really expecting it to do any heavy jobs. And speaking of heavy, the whole thing only weighs, what was it? 11 grams, I think. I weighed it before, and let me just weigh it again. It's really light, which is quite important because this is the outermost part of the arm, and you don't want it to be any heavier than it needs to be. 12 grams, there you go. So I'm quite pleased with how light it is and how well it functions given that it's so light. So on the back end here, I have not tried this yet, but the stepper motor that I'm going to connect this to has a 4mm shaft, which is going to slide in there, and then I'm going to have a couple of blocks like this out of aluminium. One's going to go on this side, one's going to go on the other side, and there'll be, well, one of them will have to be 5mm thick, and they're just going to clamp onto this piece like that, and then I'm going to drill a 4mm hole in there and put a grub screw in there to clamp it, to stop it from twisting on the shaft. We'll see how that works, but I haven't got to that yet, but I'm hoping it should work alright.